Now I'm going to talk about the third chapter of Verilog HDL and digital system design using Verilog HDL subject, and we will discuss the third chapter today. So it introduces identifiers, how to comment lines, numbers, how to use numbers, then compile directives, and system functions. Let's talk about identifiers. First of all, identifiers are case sensitive. Identifies a sequence of letters. Identifies very long any sequence of letter, digits, or characters. What is an escape identifier? Identifier provides a way of including any of the printable ASCII characters in identifier. An escape identifier starts with a backslash character and ends with a white space. White space and tabs on new line. There are some reserved identifiers called keywords which cannot be used as which can be used as general identifiers. They only be used in certain contexts. Example: always keyword, and all lowercase keywords reserve keyword and not capital letter always is not a keyword. In addition, escape keyword is not treated as the same as the keyword. Identifier initial is distinct from any other identifier initials. The backslash initial differs from initial. Now comment. Comment are of two types: one line comments and multi-line comment. This is syntax. First syntax for one line comment, and the second one is for first one is for multi-line comment, second one is for one line comment. Now format. Now Verilog HDL is case sensitive. This is identifies differently only in their case is distinct. In case Verilog is tree format, this contract may be written across multiple lines. So this here both the syntax are similar. One is written in a line format, other is written in a tree format. Now system, task and functions. Identifier function. An identifier begin with a dollar function character is interrupted as a system task or a system function. System function is a function reserved words which perform particular tasks. A task provides a mechanism to encapsulate a behavior that can be invoked from different parts of a design. A task can return 0 or more values. Remember that. A function is like a task except it can return only one value. This is the main difference between a function and a task. A function executes in 0 time. You cannot have delays in function, while task can have delay. We will have more about task and functions in later part of the video. Now let's talk about compile directive. Certain identifiers that start with the backcode character are compile directives. Compile directives which remains in effect through the entire compilation process until a different compiler directive specifies otherwise. Here is the list of all the centered compiler directives: define, undef, if def, else, and if default, net type, include, etc. So define and let's talk about one such compile directive. The define directive is used for text substitution and is very much like the defined in C programming language. So yeah, defined items compile definition stays in effect through the entire compilation. For example, MacBook's bus size across any different files. Different directives is max buses could be across any different files. The defined directive in another file. So uh, on default. So once we define a word section, we can use the word section in any other uh, file system. There are a lot many compile directives. We have already learned about the time scale compile directive in the second video. Verilog has the following 4 basic values. It is a very important thing. So we have 0, 1, x and z. The 0 indicates logic 0 or false condition. 1 correlates to logic 1 or true condition. Then we have x value, which is unknown, and the z is for high impedance. Constants in Verilog HTML are of three types: integer type, real type, and string type. Integer contains numbers which are without decimals. The real can have floating or double type of data. There is an exception that an underscore character can be used in integer or a real constant freely. So this is only the exception. Any integer number can be written in the following formats: simple decimal, base format. So let's talk about simple decimal. So yeah, this is decimal 32. Besides size, base and value. This is the base format. So in simple decimal format, an integer is in this form is specified as sequence of digits. Examples of the integer. An integer value in the form represents a signed number. So all simple decimal forms are signed number. A negative number is represented in two's complemented form. Thus 32 is 140 in 5-bit binary. Yeah. Base format. First we define sign, then we define the base, which base we are using, and the value. So it is an octal number. For example, 5037. So it's an octal number, or define the octal number. 5 is the size of the bit. 37 is the number which is indicated using number. The value is indicated using 37. So yeah, when we so suppose here is example, we have 10 stack b10. So it's 10. So the size should be 10 bits, but 10 is a value. It's a binary number. 10 is the value, and it contains 2 bytes. So rest of the bytes are filled using the 0 value. So now if we write 10 bx and suppose 0 1, then all the zeros would have been filled with x earlier. Now it's a 3-bit number, 3-bit 1001 underscore 001. So only the last three digits will be considered, because it's only the size is only 3 bits, but we have provided here 8 bits, so the remaining 5 bits will not be counted, will not be in effect. So here are some examples of real numbers. 2.0, 5.67, because since it has decimal value, so it is considered to be a real number. Strings. So strings are kind of uh, accumulation of characters. Okay. So here string is defined in register data type. So here we say the string is uh, string is of each character is represented by 8-bit ASCII. We know that character is 8-bit ASCII value. So each character is of 8-bit, and we need a group of characters to the string. So we also need a group of uh, group of uh, characters. Each character is of 8-bit, and we need a group of characters, so we need more than just 8 bits. So it is represented as 1 colon 8 into 8 is the number of the characters, and then how many characters we need, we have to specify it, and then the variable name, and then we can finally declare the variable using message equal to enter 0, and here you can count along with the space. It has exactly 14 character. Also white space is also considered as a character. The backslash character can be used to escape certain special character. Uh, so a backslash n represents a new line, backslash t represents tab, double backslash inside inverted comma represents the character itself, and you can return. You can see the example. Now let's talk about data types. Data types are mainly of two types: net data type and register data type. A net data type represents a physical connection. It can be like wires, say, between structural elements. Its values is determined from the value and on its drivers such as continuous assembly. Its values is determined from the value of its drivers such as continuous assignment or gate output. Of course, we can only assign it using continuous assignment statements. If no driver is connected to a net, the net defaults to be a value of Z, high impedance. Register type. A register type represents the abstract data storage element. It is assigned values only within a specific segment and initial segment, and its values is safe from one assignment to the next assignment. So continuous value assignment, always the values are like continuous and it's not stored, whereas register type of data type, the register data type, the value is stored from one variable, and then save from one assignment, and then we can use it in different other assignment as well. So there are different kinds of net data types, of course. First is wire, then is try, then is wire or, try or, wire and, w and, try register, then try 1, try 0, supply 1. This is syntax. We define the uh, kind, the net type, okay, try wire or wire and so on. We find the MSB, by the most significant bit and the least significant bit, and in each bytes. So what's the difference between wire and WN? Example, we performed one operation. First we assigned certain value in wire, and then we assign another value in wire. So the new values is so what will the final value be in wire? That is not sure now, because we have assigned the same, assigned multiple values to the same variable wire. But if we use wn or wor, each time we perform an operation, uh, the wire performs or and operation respectively with the previous assignment, and then source it to the w and w and variable. Here is a detailed uh, type of all this detailed uh, analysis of the net data types. In Verilog, it is possible not to declare a net. In such a case, the net default is one bit wire net. Now let's talk about register data types. There are 5 different kinds of register data types: reg, integer, time, real, and real time. So we have already talked about register, integer, time, real. This is how we declare register data types. Syntax: register can be a size, yeah. So reg is declared with the with number of bits. Here reg 3:4 defines uh, 4 bit of 4 be assigned to a variable set, so we can use set to define 4-bit numbers. Let's talk about memory. Memory is an area of registers. It's declared using reg declaration. In the example, you can see the syntax here. Yeah. So first we have first byte represent number of bytes of variable, and second 063 second 0 to 63 bytes represent the number of variables. So it's an array of variables. Read mem loads binary values, and read mem h loads hexadecimal values. This is alternate ways to assign values to a memory is using the system tasks. Integer register. An integer register contains integer values. It can be used as a general purpose register, typically for modeling high level behavior. It is declared using an integer declaration of the form here. It is the second is the way we initialize integer variables, and we also have declaration. Yeah, this is how we declare integer variable. It's very easy to declare integer variables, and it's like C and C++. Now let's talk about time register. Time register holds the current current time whole one time value. Time register is used to store and manipulate time values. It is declared using the time declaration of the form, where MSB and LSB are constant valued expression that indicates the range of the indices. Real and real-time registers. A real register can be declared using the following form. Here is the example syntax of how real registers can be declared. And here how real registers we use to assign assign numbers. So here ram count is a real integer and it has a value of 0 1. So press it. Default value of real register is 0. No bit range. Now let's talk about parameter. So sometimes we use parameter inside functions or tasks. So we can declare parameter using the parameter keyword. With this, chapter 3 comes to an end, and we will discuss chapter 4 in the next upcoming video.